For this lesson, we will be looking at algebra fraction. Those three examples that we have on that side, we intend to simplify them and write them as a single fraction. Let's look at number one. Number one says x over 2 plus x plus 5 all over 3. The question is, if you were able to do regular fractions by adding and subtracting, then you should not have problems with these. First thing we do when we observe in fractions to work them out is that we look to see, are we adding or subtracting, multiplying or dividing? We are adding fractions. Normally when we're adding fractions, the denominators must be the same. So we'd have to make all effort to get them to be the same. There are many ways people do that. But we could simply use a LCM method. So the LCM for this is 6. So we're going to approach it just like how we do ordinary fractions. 2 into the 6, 3 times. So the 3 will be used to multiply by the x, and that is 3x. The 3 into the 6 is 2 times. So we're going to use the 2 to multiply by this binomial there. So this is going to be 2 times x, it's 2x. 2 times 5, that's 10. And at this stage, we see where we could simplify 3x plus 2x, that's a 5x, plus 10 all over 6. Alright, so now you see where we move from a state of 2 fractions, and now we have 1 fraction, 5x plus 10 over 6. And you could simplify this if you want. We could factor out the 5 if we want. So people, you could go to that extent if you want to, but it's okay right now, alright? Alright, so let's look at the second example. The second example says 5y minus 3 divided by y, 5y, y plus 4. Again, we're subtracting. The denominators are not the same. We need an LCM. The beauty about using algebra fractions with binomials as a denominator is we can always write back these binomials as the LCM. So we're not going to expand this out, because the main reason why we use them is because we want to see what term we could divide these denominators in to get out something to multiply by what's on top. So y divide into y, that means the y will cancel. We'll get out a y plus 4. So we'll have a y plus 4 being multiplied by the 5 up there. So basically we're going to distribute 5 times y, 5y. 5 times 4, 20. The next move is that we intend to divide this y plus 4 into y plus 4. So if I should put my hand over it, you would see that it would have cancelled. Y plus 4, cancel y plus 4, leaving the y. So the y will be used to multiply by the 3. But this is not really 3, this is a minus 3. So it's going to be a negative 3 times y, that's going to be a negative 3y. At this stage, we can now simplify. We could call it the like terms. 5y minus 3y plus 20. And all of this is over y plus 4. You could put the bracket or not, it's up to you. Then the final thing is 2y plus 20 all over y plus 4. And as I said to you, if you want to employ a bracket here, it's okay. If you want to leave it, it's okay. This is the answer, 2y plus 20 all over y into y plus 4. Final answer. Let's look at the second case, the third case, should say, and last. Alright, so there are times when the binomials will come under your denominator in the 2 fractions. So we have a 3 over x minus 4, and we are subtracting 2 over x plus 5. Again, when we get the binomials, we could use them as our denominator. We're not going to extend not as the denominator, we could use them as the LCM, and we're not going to expand out these. We're going to keep them because we want to divide. So imagine if you divide the x minus the 4 into all of this, the x minus the 4 would cancel itself, the x plus 5 would come out. So the x plus 5 will be used to multiply by the 3. So we're going to distribute 3 times x, that is 3x. 3 times 5, that's 15. Now we're going to divide the x plus 5 into all of this. The x plus 5 would have cancelled itself. This would have come out. So it's going to come out as x minus 4. Now I want us to pay keen attention to this. A lot of times the issue that we have is that people tend to just write like this and then start working. But that's not the case, right? This is going to change everything. So we're going to take this as a negative 2. So it's going to be negative 2 times the x, that's negative 2x, and then the negative 2 times the negative 4, and that's going to give us a positive 8. And this is where most persons would have made an error. Now, after this, we could collect our like terms. So the 3x minus the 2x plus the 15 plus the 8 all over x minus 4 multiplied by x plus 5. And then from here, we could do our last simplification. 3x minus 2x is going to give us x, or some people may say 1x, but I'm not going to write the 1, but we understand it's 1x. 15 plus 8, and that is 23, all over x minus 4 into x plus 5. So there we'll have it. X over 3 divided by x minus 4 minus 2 all over x plus 5 as a single fraction is x plus 23 all over x minus 4 into or multiplied by x plus 5. Alright, there you go. Thank you for watching.